Let's run through a classic thought experiment. What would happen, step by step, if the sun were to just disappear? Not explode, not burn out, but just instantaneously vanish from existence.
So picture it. One moment, the sun is there. The next, it's gone. What's the very first thing we'd notice here on Earth? Would we feel that gravitational change right away? Well, the answer actually tells us something really fundamental about how the universe works.
For a full 8 minutes, absolutely nothing would change. Here on Earth, the sky would stay bright, the day would just carry on as normal. We would have no idea that the center of our solar system was gone. Now, this 8-minute gap isn't just a random number. It's a direct result of the laws of physics. So let's take a look at the reason behind this cosmic delay. It all comes down to what's called the speed of causality. You can think of it as the universe's ultimate speed limit. According to Einstein's theory of relativity, no information can travel faster than light. And that doesn't just apply to light itself, but also to gravity. Gravity isn't instantaneous. The news that the sun's mass has disappeared actually has to travel all the way across space to reach us. So for those 8 minutes, the last photons of sunlight are still finishing their trip to Earth, which keeps our sky lit. And at the exact same time, the effect of the sun's gravity also takes 8 minutes to fade. So we would literally continue to orbit an empty spot in space where the sun used to be. But once those 8 minutes are up, two really significant things would happen at the exact same moment. So at t plus 8 minutes, the very last photons of light from the sun would finally arrive, and the sky would suddenly switch off, plunging into darkness. And in that same instant, the sun's gravitational pull would cease, and the fabric of space-time around us would flatten out. Without the sun's gravity constantly pulling it into that curved orbital path, Earth's own forward momentum, its inertia, would completely take over. The planet would stop orbiting and just keep going in a straight line. It would fly off tangential to its old orbit, kind of like letting go of a rock you're spinning in a slingshot. And we'd be moving fast. Our speed would be our old orbital velocity, about 30 kilometers per second. To put that in perspective, that's nearly 70,000 miles per hour. Earth would officially be a rogue planet, hurtling into deep interstellar space. You know, it's helpful to compare this whole thing to something we're more familiar with, like a total solar eclipse. During an eclipse, you get a temporary twilight, and the temperature drops just a little bit. But in our scenario, the darkness would be permanent, and the cooling would just keep going, getting more and more severe. The only light left would be from the distant stars. With our main heat source just gone, Earth would immediately start losing all of its stored heat out into space. Now, our planet holds on to a tremendous amount of thermal energy, especially in the oceans and down in the core. But without the sun's energy to constantly replenish it, Earth would just radiate that warmth away into the near absolute zero cold of interstellar space. The cooling process would be pretty quick at first. Within just a week, the average global temperature would be colder than the coldest temperature ever recorded in Antarctica. A couple of months in, a crust of ice would start forming on the oceans. And over the next 1,000 years or so, that ice would just get thicker and thicker until the oceans were frozen completely solid. The extreme cold would also cause our atmosphere to collapse. First, all the water vapor would freeze out. Then, at around minus 78 Celsius, carbon dioxide would turn into snow-like dry ice. Eventually, as it got even colder, the nitrogen and oxygen that make up our air would turn into liquids, rain down to the surface, and freeze, leaving the planet in a near-total vacuum. So what we have now is a frozen, airless planet just traveling through the galaxy. Let's think for a moment about its long-term journey. At this point, our planet would be classified as a rogue planet, which just means it's not gravitationally tied to any star. It would just drift through interstellar space, and it could do that for billions and billions of years. We would also lose another really important form of protection. The sun's magnetic field creates a huge bubble around the solar system called the heliosphere, and it shields us from a lot of high-energy cosmic rays. Without it, Earth would be completely exposed to all that harsh radiation. Okay, so the surface would obviously become completely uninhabitable. But that raises a pretty interesting question. Could any kind of life on Earth possibly survive this? So the question is, could anything make it through this? The surface is clearly a lost cause. But what about way, way deep down inside the Earth? Well, the energy we get from the sun is thousands of times greater than the heat that flows out from the planet's interior. But with the sun gone, that tiny little trickle of internal geothermal heat becomes the single most important factor for any possible survival. This internal warmth comes from two main sources. There's leftover heat from the violent collisions that formed our planet billions of years ago, and then there's the steady, slow decay of radioactive elements deep within the Earth's core and mantle. Now, here's the really fascinating part. That shell of ice covering the planet, kilometers thick, would actually act as a fantastic insulator. It would trap that geothermal heat, stopping it from radiating away into space. And this could allow a layer of liquid water to exist at the very bottom of the deepest oceans. And in this deep, dark, liquid ocean, certain forms of life could actually continue on. See, the ecosystems around hydrothermal vents don't need sunlight. They use a process called chemosynthesis, which means they get their energy from chemical reactions, not from light. And as this quote suggests, this kind of life could survive for an incredibly long time. So if the sun vanished, life on our planet wouldn't necessarily be extinguished completely. It would just retreat deep into the oceans, sustained by the planet's own internal heat. It just goes to show how resilient life can be, surviving in conditions we can barely even imagine.